Okay, let's start with practice A, centripetal acceleration. And let's look at number 1. So number 1 says a rope attaches to a tire to an overhanging tree limb. A girl swinging on the tire has a centripetal acceleration, so we're given the centripetal acceleration is 3 meters per second squared. If the length of the rope, so now if I'm not sure, I can draw a picture. If someone's on a tire swing, she's going like this, right, back and forth. So this is like if I was to extend it, even though she's not going completely in a circle, you see how it's going in a circular motion? So the length of the rope is the radius of the circle. What is the girl's tangential speed? Now we know that the speed always acts what? Tangent to the circle as it's going around. So the speed is always tangent to the circle, so that's what we want to find is the tangential speed, which we'll call Vt. So the basic equation is centripetal acceleration is the tangential speed divided by r. But since we have a and r, we want to solve for v. So I'm going to rearrange the equation that ac times r is equal to vt squared. But since I want to solve for Vt, I'll take the square root of both sides, so the square root of ACR is equal to Vt. Now I'll substitute in my value. So we always want to solve for the unknown in terms of the known, so we don't make a mistake. So when I multiply 3 times 2.1, and then I take the square root, so Vt comes out to be 2.5. Now, before I go ahead and write my answer, which I know is supposed to be meters per second squared, let me check my unit. So underneath my radical, I have meters per second squared times a meter, which is a meter squared over a second squared. When I take the square root of the number, I also have to take square root of the unit, so it ends up being a meter per second, which is the correct value for the tangential speed. All right, now we're going to look at practice B. And for practice B, we'll also do number 1. Or, you know what, we'll do number 4 since that one's the most difficult. How's that? So number 4 says a 905 kilogram car, so we're given that the mass of the car is equal to 905 kilograms. It travels around a circular track with a circumference. So now I'm given the circumference of the circle is 3.25 kilometers. Now first of all, I want to change the kilometers to meters because I know I don't do stuff in kilometers, so it's 3250 meters. If the magnitude of the centripetal force, so now they give me the force, is equal to 2140, what's the car's tangential speed? Now, they gave me circumference, and I don't remember circumference in anything. When you don't know what to do, the first thing you do is you go to the end. So when I say go to the end is, what do I want to find? I want to find the tangential speed. Well, I know that centripetal force is equal to mvt squared over r. Now, when I start looking at everything, I know that I'm given the centripetal force. I know the mass. I don't know the radius, but I want to find the tangential speed. So now I see that if I find the radius, I'll easily be able to find the tangential speed, right? So what I'm going to do is I'm going to rearrange this equation to solve for the Vt. So first I'll multiply both sides by r, so centripetal force times r is mvt squared. I'll divide both sides by m. So FC over R divided by M is equal to VT, and then I'm going to take the square root of both sides. So the square root of centripetal force times the mass times the radius over the mass is equal to VT. The problem is I still need the radius. So now I'm going to look over here and say, how can I find the radius? Obviously, I'm going to have to use this information. So now I have to say to myself, is there a relationship between circumference of a circle and radius? Yes. I know the circumference is equal to 2 pi r. So now I'm going to rearrange this equation and say circumference over 2 pi is equal to r. So the circumference is 3250 meters divided by 2 pi, and that's going to give me my radius. So when I do that on my calculator, the radius comes out to be 517.5 meters. And then I will substitute that up here. So the tangential speed is equal to the centripetal force, 2140 newtons, times the radius, 517.5 meters, divided by the mass, which is 905 kilograms. And when I do that on my calculator, it comes out to be 35. But I want to check my units to make sure I didn't make a mistake, because when I carry my units through and cancel them, it checks my work to make sure that I didn't make a mistake. So let's look at that. Underneath the radical, I have a newton, and a newton is a kilogram meter per second squared times a meter divided by a kilogram. So what I see is the kilograms cancel, and then the meter times a meter is going to be a meter squared divided by a second squared. When I take the square root of the numerical values, I also have to take the square root of the unit, so I end up with meters per second, which is the correct unit for the speed. And that's it.